Hey guys, what's up? Welcome back. Glad you could all join us here today. Hope you like what you see hanging above us, because what it is the newest, most up-to-date photo boost reference design using the Pacific Light Concepts photo boost strips. Now this is the one that everyone wanted to see. This is the bigger build, the 645 watt, 1700 micromole total output, 1000 watt, 4x4, 5x5 area comparable here. This is the light you guys all wanted to see. So that's what we're doing here today, putting it together. We're using the newest components, be it the spine, the heat sinks, everything about it is the most up-to-date, and we are going to show you everything you need to buy and how to put it together right here in this video and build this light for around 800 bucks. So stay with us. Alright, so let's build the most up-to-date photo boost reference design there is. This time we're not going to leave anything up to imagination. We're going to be building the big design, the 16 strip, 600 plus watt, anywhere honestly from 575 watts up to 750 watts this system can easily handle here. Photo boost reference design. So really, just like all the build videos, we're going to go over the components, what they are, what they do in the build, as well as where to get them. Now before we go any farther, everything you see here on the table, as well as everything you see in this build is available in the description below this video on YouTube, as well as if you go to pacificlightconcepts.com, go to the photo boost page where you buy the actual strips. Right at the top there it says photo boost reference design, click there, as well as at the very bottom of the page it says photo boost reference design BOM, B-O-M, build of material. Click there, it'll take you to everything you see here, the names of it, how much of them, and the links of where to get them. If for whatever reason those links are out, use the description, find something similar. That is the beauty of this reference design, is how simple it is, and it's made with basically readily over-the-counter available parts. There's nothing really major. The photo boosts are the only thing that are kind of, quote-unquote proprietary in any manner, when they're nothing crazy to them, but they are made by Pacific Light Concepts exclusively. The rest of this is all just basic electronic components and structural components. So, alright, so the main component of the whole build that makes it so special is the Pacific Light Concepts photo boost strips, using the Samsung 301B diodes combined with, this is the only addition to them since the original build, is that they're now using the Cree XPG3 red. Wasn't originally available when the photo boost strips were designed, now it is, so we're using the most efficient white diode in the world on top with the most efficient 660 red diode in the world right now. So you're getting everything you can from the LED world in this strip, as well as in a very well proven horticulture specific kind of slightly tweaked red enhanced spectrum there. We're using 16 of these strips. When you buy them from Pacific Light Concepts, they come wrapped, 2 per package. And like I said, we're just going to be using 16 of these per strips, and we're going to be driving them at a very nominal, the recommended current of 1400 milliamps. Kind of the most bang for your buck as far as output and extremely high efficiency. Great, very similar to the old build. Next is a new one to the build here. We have the Pacific Light Concepts heat sinks. Now these are heat sinks they sourced specifically to run these strips. They have a hole pattern so that you can fasten them down with screws if you choose to. If you do use screws, you need to make sure we use nylon washers every time. That is a must. But anyway, you can also use thermal tape, and that's what we're going to be going here, but we'll go into that in a little bit. But anyway, these heat sinks are much better than the Heatsink USA profiles, the 1-inch profile from the original build, specifically in heat capacity and thermal ability there. These things can easily take up to basically 2100 milliamps to the strips on these heat sinks. That's about the limit there, but they will handle it very well. Right there at around the 80C on the dye temp, and 1400 and below, the dye temps are fantastic. In the 50C and below on the dye, it's incredible. These heat sinks definitely make the build run much cooler, and structurally they're also nicer as well, which we'll get into, since the next major component is the spine, or the structural aspect of the build, and you can see that at the very beginning of the completed light. But last time we used single 80-20 extrusions, 1-inch profiles, or 10 series profiles they're called. This time, instead of using 2 on the end, we're using what we call a spine up the center. Some of you guys might compare it to like a spider design, and it's similar. But this is it right here. What it is called a 1 inch by 3 inch 10 series profile, made by T-Nuts as well. I'm sure you can find them elsewhere, but what this allows us to do is attach these heat sinks directly with one nut and T-nut, or one bolt and T-nut right here to it, as well as be slightly adjustable. It's a fantastic addition and is what really takes the build from very easy with minimal fabrication needed to a complete, basically plug and play, turn and screw right out of the, very, very easy DIY build. Now the last component, or major component, before we get into the little tidbits to put it all together, are the power supplies. Now this is a topic that I get asked a lot of questions on, and when we get into wiring specific, or you can just go to the timestamp at the very beginning in the table of contents here, we'll get into different power supplies, how to utilize them, and whatnot. But long story short, I always recommend 2 HLG 320s for this particular build, and a lot of people ask why not 1 HLG 600. And long story short is you get more bang for your buck, wattage wise and overall output with the 2 drivers. It's not much more complicated to do at all, and it actually guarantees the strips run perfectly in single series constant current. It's just a slightly better way than the comparable readily available options. So my main reason behind that is because with HLGs, or Meanwhile HLG driver line, which are readily available to almost anyone in the DIY world, this is what you have to work with. There are other brands of drivers out there like Autech, Invitronics, Powerland, that make some very nice 600 or 700, 680 watt drivers. They're fantastic, but the DIY world just really doesn't have access to them. They're kind of like through distribution only, large orders, large minimum orders. So those, if you can find them, great. But these are the most readily available options, and the 2 driver HLG 320s is just a better option than the single HLG 600. But in this video, we're going to show you how to do them both, so no big deal. Lastly, we kind of come over to the tidbits that put this all together. Now, again, all the links to everything you need here, quantities of them, are in the description below, as well as, like I said, on the PhotoBoost website in the spreadsheet there. But a lot of this is done thanks to T-Nuts and the ability of aluminum extrusions. We're using just simply 8 1-inch screws with a washer and a T-nut to attach this heatsink to this spine. We have 1/4-inch or 1/4 eye nuts so we can hang it. We have a power box. This is linked in the description. We're going to be using, depending on what driver setup you use, you may use 1 or 2 of these power boxes, or if you want to modify it, you can always use 1. And of course, we're going to have our handy dandy Wagos to connect any wires. I gave you a variety pack below that'll have enough to do either one of these builds, but if you just buy 3 packs, you should be okay. But if you do the parallel, it pays to have the 5s. So anyway, the variety pack, not a bad bang for your buck. And on top of that, we also have thermal tape. Thermal tape, thermal tape, thermal tape. It's what allows us to roll this out, put it together very quickly. There are some downfalls of this. Obviously, it is tough to get off if you ever want to change the design. So think about that. It's doable, but it is tough. So just know that. If you want to change the design, you think you're going to be moving your strips off heat sinks onto something else one day, go with screws. Now, if you do go with screws, I said this before, nylon washers. It's a must so you don't scratch the PCB, cause any shorting. Nylon washers will save your butt. They're just a couple cents for, it's like $1 for 100 or something on there. Last but not least are gland connectors. IP67, IP68, even IP66 is okay. Gland connectors. They're very easy to come by, very easy to use. Essentially, what they will allow us to do is connect cable to cable. So this will be able to connect our driver cable to any kind of extension DC cable we want, or AC. Then we also have T versions like this that will allow us to connect 2 driver power cords to one, or 2 driver powers to 1 power cord to the wall. That's a common question we get asked, and is kind of a complaint of the 2 driver setup. You can easily put 2 drivers to 1 power cord to the wall. Saves you right there. And if you're using an HLG 600 in a series parallel configuration, this will allow you to take its 2 DC outputs and combine them to 1, so you can have 1 line running to the fixture with the HLG 600. So these little 3 terminal or little T connectors here. These things go a long way. Now, like I said, this build is super easy, doesn't take any fabrication thanks to T-nuts, the holes we have in the heat sinks, and it allows us to use almost minimal tooling to get it done. The only thing we're going to need to get it done at all is a Phillips head screwdriver if you are using these connectors. If you are not using these connectors, this Phillips head's not even actually used, an Allen wrench or maybe a Phillips just to tighten the bolts. I always recommend hex heads or stars if you can get them, construction heads, whatever, just because you can torque them down a little bit better than a Phillips, but some of you guys might end up with Phillips heads for these screws, so whatever it is. A razor blade so you can cut the thermal tape, and wire strippers so we can cut wire and strip them. This is probably your most useful tool in the whole build. Other than that, it's literally just plug and play, so very, very easy. Let's get into putting it all together. Okay. It's time to put this whole thing together, and once we start getting going here, putting the heat sinks on the spine, it begins to look like the unit as you know it very, very quickly. So in order to put the heat sinks onto the spine here, we're going to use a 1-inch screw or bolt or whatever you want to call it, and a washer. And the washer that I have right here, it's a 20 millimeter washer, which is about 3/4 of an inch. I wouldn't go any bigger than that, or you might run into issues with the touching the boards, not having enough room. So try to get a washer that's less than 3/4 of an inch. In order to do this, we're going to use the hole in the center of the heatsink right there with the screw and the washer, and on the back side we're just going to attach a T-nut and just thread it on a couple threads very lightly there. And that is really pretty much all we need to do to be able to attach the heat sinks to the spine. Go ahead and do that to the rest of them and get ready, and we will put it all on here. So just as I said, we are going to be taking that T-nut that we lightly threaded on, and we're just going to put it in the center channel here. There's 3 channels. We want it right in the center channel. It should slide right in. If not, loosen it up and it'll slide right down. So just go ahead and begin putting them all on, and try to evenly space them about 5.5 inches. Okay, so once you've got the heat sinks slid onto the spine, we're just going to space them out evenly as you can over your spine. Now for a 4x4 area, I recommend a 40-inch spine. Now the reason is because the strips have the most spill this way, as where this way they have the least. So we want this 46-inch length, and this we want around 40 so it spills extra. If you're doing a 5x5 canopy, you might think about getting a 48-inch spine and spacing them accordingly. But anyway, for this build and the 40-inch spine, it works out to, you lose about 3/4 of an inch each side, and it works out to around pretty much 5.5-inch spacing on center, from center of this heatsink to center of this, to this, to this, to this, and so on. 5.5-inch spacing across once you line them up on the outside. Once you do that, go ahead and fasten them down. Get them as tight as you can. Don't go, total Hulk, but get them down quite well. If I was going to say the weak part to this design is just the fact that we're using one screw or one thing in here gives a pivot point, so if they're not tight or you bump them, you might get a little bit of movement, so go ahead and torque them down pretty good. Now once the unit is up and hanging, you shouldn't have any issues at all, but if I was going to say the weak point of the build here, just that little bit of movement, but overall nice and secure, and we essentially have what you see as the low profile linear design. Okay guys, time to take your boards and get them ready to put onto the heatsink structure there. Now like I said, there's 2 ways to do this. We can either do it with thermal tape, or we can do it with screws and nylon washers. Like I said, if you're using screws, nylon washers are a must. Now if you're using screws, the size is M3, metric 3mm. That is the size that the heat sinks are tapped for, as well as the boards are ready to accept. For my builds, I always recommend thermal tape. It's slightly more permanent in the sense it's tough to get the boards off, I will admit, but I don't change my designs much, and if I do, they're still going to stay on the same heatsink. They're just going to get moved around a little bit. So thermal tape works great for me. You can also do a combination of the both. Some people like the extra security of maybe a screw at each end and then thermal tape the rest, or thermal tape with screw at each end. It's really up to you. Again, for me, thermal tape performance-wise across the board is works just fine, if not is superior. So what we're going to be doing is just applying thermal tape to the back. Just flip the boards over very easily, nicely. They shouldn't really touch, the diode shouldn't touch any surface. Then we are just going to take the thermal tape and lay it across. Okay, we're just going to flip the board over. Align the tape as best you can. You can either center up the tape or line it on one side. The closest thermal tape we can get is 30 millimeters wide. The boards are 25. So we have a slight bit of excess here. All I do is take a razor blade, trim up both ends, and slice it right there. And that'll peel off nicely, and you have a nice 25 millimeter wide thermal tape. Then we'll begin to put these onto the heatsink structure. Okay guys, so I've begun putting the boards onto the heatsink structure here, and it is exactly as easy as it sounds. We are just peeling and sticking them onto the heatsinks. Now I'm not using screws, but I am aligning the screw holes up so that if I wanted to add them, I could, but also just spacing wise, it works out very nice. They're more or less centered on the heatsink, so that's how I'm doing it, and that'll give you enough room with your washers. If you want to put them all the way out to the ends and you're using thermal tape, you know, that's completely up to you. But the kind of one key to placing them is on each side, we want them to all go the same way, but we want them opposing on each side. So what I mean by that is, you can see here, all the boards that are put on so far have the Pacific Light Concepts logo at the bottom. So bottom. So if you're standing over here reading it, you can read all of these. Now going up the other way, we are going to do them the opposite. So the logo over here is on this side of the frame. We are going to turn that so now on this side the logo is on my left, or camera right, however you want to view it, but the logo is on this side going down here. What that is going to allow us to do is have very simple wiring across, positive and negative for series, as well as building up 54 volt strips for parallel. So that is the only kind of secret thing to do when you're laying the boards onto their heat sinks, is just, again, all the logos facing one way on one side, all the logos facing the opposite way on the other. It's going to make it a lot easier for you. So like I said, it is just as easy as it seems. We are just peeling this blue side off the back of the heatsink here and aligning it up. Now the heat sinks, let me get this blue, takes a... Now my one tip is these boards fit very snugly into these heat sinks. So it doesn't take much, but don't be afraid. Don't be afraid to push them down in the slot a little bit. You know, I'm going to line them there, and I'm just going to lay them in, and I'm going to push not on the diodes, I'm going to push on the board, but I'm going to push all the way down, because right here you can see it's a little tight. A little click, just drop down into that slot fully, and make sure it's good to go. I'm going to do that to the rest of the boards, peel and stick, and then we'll get into wiring this up, and we're that much closer to the end of this build, guys. So stay with me. Okay guys, here it is. I mean, like I said, it comes together looking like the light as you know it very, very quickly. So now that the boards are on, however you choose to do that, we got to wire these things up. And like I said, when you lay it out, it's very important that we have the logos facing one way on one side and one way on the other, because it makes it very easy for both series builds or parallel builds, whichever you end up going with. That layout is going to help you out. Now, I'm going to be showing you guys right now how to do a series build, a pure series build, and that is for 2 HLG 320s. And essentially how that's going to end up working is we're going to have one HLG 320 controlling these 4 strips and one HLG controlling these 4 strips. And it's very, very simple. If we were to start at the open negative right here on the middle of the 4th strip, we would then go from the positive to the negative, positive to the negative, positive to the negative, positive come across to this negative, and then like I said, because we have those boards flipped, this makes it very easy. We go positive to negative, positive to negative, positive to negative, and then we have our open positive lastly here for the driver, and we're going to mirror that right on the inside. So one more time. So let's go over it one more time, and I even have the driver in position here. Don't ever leave open exposed wires out of the connectors like this. I just have this placed here for demonstration purposes. But anyway, as you can see, we have the positive from the driver over here and the negative from the driver over here. So let's go over the one single series circuit real quickly, starting from the negative, since DC does flow from negative to positive. We're going to go driver negative to this terminal, then out of its opposite positive, we go positive to negative, positive to negative, positive to negative. This positive right here is coming across to this negative. Again, this is the importance of switching the way the boards are facing. Then we continue on, positive to negative, positive to negative, positive to negative, and lastly, the driver positive. So right there, that is one single series of 8 strips. Again, 8 strips in series off one HLG 320 14-B. Could also be -A. We're going to mirror that on the other 4 strips, and then the whole light will be ready to accept power, and we'll start to get that going. Okay, let's wire it up. Again, we're going to start here. We're going to go positive to negative, and then we're going to push these down into the channel. That's the best thing about this 80/20 extrusion here. You can also get it in black, I might add, but hides wire very well. Another positive to negative here, and just continue making this connection down and hiding the wire in. Okay, and the last little piece is the final connector across the end to complete the series. I just make a nice little bend like that, and then it can drop in there. And that is the complete circuit. Now right there we have the waiting terminals. If we move this over just a little bit, we have terminals on each side here for this bank's positive and negative, and then this bank's positive and negative right there waiting. So we have the unit basically ready to go. Boards are on, structure's made. It's just essentially waiting for power from whatever driver situation we figure out. Now, like I said, the most recommended setup for this is 2 HLG 320s. It's most bang for your buck. It's going to cost the same as an HLG 600. It's going to get you more wattage, and it's really not very hard to set up at all. Actually, I've got in front of us here, I have 2 different ways to set it up. I have a more fancier, clean, tight IP67 gland connector way, and then I have this same exact job done here simply with Wegos or wire nuts, however you want to do it. Take the complexity out of it just to show the general concept. So what I like to do is I like to use wire glands, cable glands, nice little junction boxes to clean up my dimming leads. I like to make it look a little clean. You guys have all seen the driver board in my room. That's where these came off of. I've got 4 drivers running 2 different lights in my room. I have a 4x8, and each light is controlled by 2 of these 320 drivers that I have set up on the wall. Well, when you use 2 drivers, the biggest complaint I get is there's 2 power cords. I don't want 2 power cords running to the wall. Well, that's no big deal, guys. We can make 2 drivers into 1 power cord very, very easy. Now, like I said, what I have here is cable glands. Inside these cable glands, they have numbered or lettered or colored terminals. It's either terminals 1, 2, and 3, L, N, and G for live, neutral, and ground, or sometimes they're just colored, black, silver, and like a bronze. The concept is we're putting all the black wires together, all the white wires together, all the green wires together. Sometimes it might not be black and white wires for positive being black neutral being white. It might be brown for hot or live and blue for neutral. Anyway, read the legend on your driver, whatever driver you are using, and just make sure that you're paralleling all the AC lines together. Like I said, I did that with a beautiful cable gland, works great, but you can simply take a 3-terminal Wago and attach both the lives together, both the neutrals together, and both the grounds together to one single power cord out. Doesn't matter if it's a 120 power cord or a 240 power cord or a 277 power cord for that matter. These drivers here, the HLGs that I recommend, will accept anything from 90 volts all the way up until 305. So it basically covers everything from your 110 to your 277. Same thing on the other side. There are 2 DC output leads and there are 2 dimming leads. Now one of these we can combine into 2 very easily, just like we did the AC side. We can take the dimming side and combine it into one single dimming terminal here. Now right here on this particular build, I used the same project junction box that we're going to be using to fasten the DC lines to the fixture. I used here to put my dimming leads in, as well as a 3x5, which is an audio jack, a 3.5 millimeter jack, so I can use these on Trollmaster specific. If you're not going to use these on Trollmaster or anything else, you can just simply put a basic potentiometer here, and that's exactly what I have on the more simple setup here. I have more 3-terminal Wagos, and we've attached both the positive dimming leads together to the positive of the potentiometer, and both the negative dimming leads together and to the negative of the potentiometer. And when doing so, that will make both these drivers dim simultaneously off this one potentiometer, and for the 660 watt or 50 watt unit that we have, will make the whole light dim as one light, which is I think what people want. Now lastly on here is we have the DC line. So DC meaning the power running from the drivers to the lights themselves to the boards. Now we're going to have 2 of those lines, meaning 2 power cords running from the drivers to the lights, or if your drivers are on board with the lights, you won't have 2 power cords, but we will have 2 lines running. I don't think that's a big deal. I think you guys can handle it. It's easier, and like I said, it's more bang for your buck. There's a reason we're doing it. It's not just because I want you to run 2 DC lines to the driver and make it harder on yourself. I'm doing this because it gets you more wattage, more bang for the buck, and all it is 1 additional line. Now for the nice complicated setup, I use these cable connectors. Okay, so now for the DC side, and it's essentially the same thing as the AC, we're just obviously dealing with different wires here. And that is important. Obviously the DC out of the driver does not have a ground, it's just a positive and negative, and I talked about it earlier, we're going to be adding a ground. So on the driver side of the connector, we have the brown going to the L connection, which stands for live, so that's considered the positive in this instant, and the blue wire going to the N for the neutral line, and that's signifying for the negative here on the DC side. And that would leave the ground open, but like I said, we're adding a ground, and that's going to happen right here. So in addition to feeding the DC in through this gland, I've also gone with just the standard 18 gauge wire that I told you guys to get here. You can use any wire to do this, but the solid's nice because you can jam it up through the gland and attach it in there. So anyway, a solid piece of wire here that's going to run back and attach to the driver right in the center hole. We'll look at that in a minute. Anyway, so on the driver's side we have L to the brown, N to the blue, and G is going to go to whatever ground wire you choose. Now we move to the other side going towards the light, and we are using an AC power cable here, but we have to remember we're using DC. So now white is positive, black is neutral, and green as always is ground. So to the L, or the live, we put white. To the N, or neutral or negative in this instance, we put black, and G, as always again, is green and ground. And that'll show up on the other end. As well as some quick connect cables that can plug right in. That way I can have this end hooked up to the light and have the light with a long 10-foot power cord that just plugs quickly into my driver setup. Nice little snap and click, and I have this, I'll have two of these running to my lights, and this end right here would plug into my strips. We're going to do one more step, but for the sake of concept here, these would plug straight in and provide power. So we would have two of those. Like I said, I used a cable gland and a quick connect here. For those of you out there who don't have a quick connect because sometimes they're hard to come by or they're not really necessary, it's just another step, you can go straight cable gland from the driver to any generic power cord you have. So this is just a cut up power cord. We've got a green for ground, and then we have a white and a black. Since this is DC, we're going to be using the white as positive and the black as negative. For the AC side, that's switched. For AC, black is always hot, white is always neutral. For the DC side, that's switch. So the simplest way to do this would just be to take your dimming leads or your DC leads from your driver and is to connect the white to the gray or the brown for meanwhiles, and the black to the blue with the black stripe on it. Right there, this gives us a DC line from this driver to the end of this power cord. Okay, so here's a quick overview of the driver setup. We've got the slightly more sophisticated wire gland project box quick connect version here, and we have the slightly straight to the point Wago method here. So go over it one more time. We've got the two AC lines, one from each driver here, connected to one power cord via one of these T gland connectors. We also have both the dimming leads, the positives connected to the positive and the negatives connected to the negatives inside this box. This can be done a different way as well. We have each one of the DC lines out to the driver running to the unit. We're using these cable connectors, cable to cable connectors here, as well as the optional quick connects. Again, these are optional. The concept of two DC lines running out to your unit is what to take up here. Now, if you don't want to use all those fancy $3 connectors and whatnot, totally understandable. You can use some 10-cent Wagos. The same concept that went on in here in this nice little plastic mold goes on right here with Wagos, wire nuts, whatever you may be. Same concept continues on down the line. We've got one DC line running to the driver here, one DC line running to the unit here. These are, again, just connected with Wagos, very, very simply. And then lastly, we have both the dimming leads here connected to one single dimmer, positives to positive, negative to negative, and that will allow these pair of drivers to dim as one single unit. We have one more step here. We need to connect these DC lines to our unit, and then we can plug this in and fire it up. All right, so we are essentially on to the last part here. We've built the frame, the structure, put the boards on, did the essential wiring on the unit. We've also put the drivers together, the two HLG 320s, 1400s. We've either done it nice and clean with wire glands, possibly quick connects, who knows, done some slightly cleaner wiring, we'll call it. Or you may have done it with the Wagos, and there's nothing wrong with that. The get her done method works just fine. Wagos are perfectly safe. Totally fine. But now, like I said, whichever method you've gone with, you now have two DC lines. Whatever it may be, you have two DC power lines running from your driver setup that need to get to the unit. Now, obviously, you could just plug them into the boards, but who knows? I could yank a connector off. You could, but you shouldn't. That's what I should say there. You could, but you shouldn't. So what we're going to do is make a slight little station right here using one of these IP68 little junction box here. We're going to put exactly that, a junction point for the DC wires coming into the unit to be secured here and then go out to each bank of strips. So like I said, to do that, we're going to be using one of these IP68 underground junction box. They come in a variety of flavors, we'll call it. But the most common one that we use here is just this 2 PG9 gland. They also make a 3 gland version. So you've got 1 gland, 2 gland, and a 3rd gland. And that is actually going to be quite useful once we get going, because I think the third gland for how I'd like to wire this right now would just come in handy. But that's okay, we don't need it. We'll just drill a hole and come out of it. So that is exactly what I've done over here on the complicated side. We have both of the DC lines coming into this box, and at which point they then branch out into two separate circuits, the two separate circuits that they are. We've got a positive and negative coming from one branch of wire, so this branch is positive, negative comes out here. This branch is positive and negative comes out right here. Now, in addition to that, I also have a T-nut drilled right through the center here. You can use these mounting holes, but they are slightly small and they might bust open. It'll still hold it down just fine, but for extra security, I have drilled a hole and I'm using a standard T-nut with a 1/2 inch screw and a T-nut right in the center here. And what that allows us to do is, just like the heat sinks, just like everything with T-nuts, we can just slide it in right there. Once you have it on there, take that T-nut and we're going to secure it down to the unit. Once it's secure, the glands are tight, the fixture is good to go. Now, I don't recommend doing this, but just to show you how strong they are, you can lift up the unit on the glands. Not ideal, again, don't do it, but it is strong enough to hold. So that will secure this on here, and now we have these 4 wires here, a positive and negative, one from each driver, to go underneath to the boards. That's exactly what we can do. We can flip them up right here, and we take one set of wires here, one positive in here, and its corresponding negative to the negative terminal over here. That circuit is set. What will be a negative wire up here and a positive wire down there. Positive in there. Negative in there. And at this point, we have 2 circuits. 2 full circuits where we have 8 strips going out this way and around, and we have 8 strips going out this way and around. Okay, so now that we've actually, hooked up our wire junction box here to the boards, we're ready to apply power to the whole system. You guys have done all the hard work. You've put the boards on the heat sinks on the frame, wired the boards up initially, you've built the driver setup, you combined them to one power cord, you got your DC outs running and locked into the unit here. Like I said, it's time to fire it up. Make sure all is good and working. Boom. And just as it should, the system fires up to full power perfectly. Now at full power and 120 volts AC, you're going to be getting right around 640 to 650 watts at the wall. If you run that on 240 volt or even 277 volt, you will get a little bit more driver efficiency out of it, but your total output at the diodes will be the same. So you might get around 630 watts at the wall, but don't worry, you're getting all the output plus a little bit better efficiency if you run those higher voltages input. But regardless, the system's at full power, ready to go. Now, like I said, we got one little thing to do. We're going to put the cap on this junction box, but there's only one last step at this point, and that's to be able to hang this beautiful light. We want to be able to hang it so we can show it off, so we can put it over plants, whatever you need to do with it. And to do that, we're going to be using 1/4-20 eye hooks or eye bolts. These are just from Home Depot. You can get them anywhere. You can get them online, Amazon. And we're using, since they're 1/4-20, we can use a T-nut with them, and that's exactly what we're doing. I'm actually going to power this down for you guys. Oh, sorry. Actually going to power this down for you guys so you can see what I'm doing. And we're just taking this T-nut extrusion here and the eye hook and just sliding it right in and torque it down. Sliding it right in and torquing it down. And right there, guys, you're hung. So all we need to do, we have a fully functioning working light and the most up-to-date, easiest to build photo booth reference design.